We get sine x. Okay, and then we get 1 minus cos squared x over sine x, which is what? Sine squared x, right? Now, guys, I just want to draw your attention to this. If it's 1 minus sine squared x, I see this all the time, over sine x, I see people doing this. Can you do that? No. This has a what in it? Minus sign, even if you had a plus sign. These are attached. You can't get rid of that unless you'd like, you could take the difference of squares of that. You could go like 1 minus sign, 1 plus sign. You could try that route. It would not be helpful in this instance, but you could try that. This is actually as like low as it could go if you had that. Okay? So here, or you could change it to cos squared x, and then this would be cos squared of sine. Anyways, this can cancel that off, and we're left with sine x. This one, we have an equal sign. So whenever we're doing simplifying, you run equal signs down the left-hand side because you're just having this expression equals this expression equals this expression. So you should have equal signs. I know when we've talked to profs in the past, that's the biggest complaint is no one uses equal signs. They use like arrows or random things, but not equal signs. Yeah. No, you can go horizontal. Proofs, you would go vertical. But like just a simplification, you could go horizontal. When you have two sides of an equation, always vertical. But one side you can. So we get sine x over 1 plus cos x over sine x times cos x over 1. What do I have to do over here? Yeah, multiply by sine x so that I get a common denominator. So I'm going to get sine squared x over sine x plus cos squared x over sine x. Now that we have a common denominator, we can write them all over sine x. So we get sine squared x plus cos squared x, which is 1. Off the formula sheet. So it's just 1 over sine x or cosine. Yeah. Most often they'll say a single trig ratio. So then you would, well, or to be a multiple choice, you can match them. All right. 3. Cotan theta over cosecant minus sine theta. I think it's cosecant, yeah. And then I wrote cos. And then you're going to try secant squared x minus 1 times cotan squared times sine x. Try those out. So we're going to have cotan, which is cos over sine, which immediately makes us have a fraction on the top, which immediately means we're going to write them sideways. So we're going to get equal sign cos theta over sine theta. And because it's in a numerator, I'm going to put it in brackets so that I know that that's the numerator, divided by cosecant, which is 1 over sine theta, minus sine theta over 1. I cannot flip anything. We talked about this yesterday. You cannot flip anything unless you have a full fraction divided by a full fraction. We agree? So that's why I put the numerator in brackets and denominator in brackets, so that unless those two brackets are perfect fractions, you're not doing anything. You got to make them perfect fractions first. So I need to multiply this side by sine to get a common denominator. So I'm going to get cos theta over sine theta divided by 1 minus sine squared theta over sine theta. Now do I have full fractions? Yes. So now I will be able to flip. So I get cos theta over sine theta times sine theta over 1 minus sine squared theta.
Transform the 1 minus sine squared theta, like, this point to...
Yep, you can do it whenever.
Okay,
You could
so
flip it and
doesn't
change
really
it.
matter if you do it before, like, at the end?
Right. So you could have went and, if this was me, I would flip it and change it now. But I didn't want to skip a step and lose people.
Okay.
Then, because this sign and this sign have no plus or minus signs attached to them, they can actually cancel. But can I cross this sign at the top off with the one right below it? No, because this is a plus or minus sign, right? But, like Shane said, we could change it to this being all over cos squared theta. It'd be cos times 1, which is cos, and then 1 times 1 minus sine squared theta, which is cos squared theta. Then these cancel, and what am I left with on the top? 1 over cos theta, which is actually secant theta. Number 4. What the heck can I do? Yeah.
I don't know if I did this right stuff, but I changed the secant, or yeah, the secant squared x minus 1. I changed it to tan squared x, and then I put, I don't know if you're allowed to do this, but then I put sine squared x over cos squared x for it.
So remember all the single ones, we went over this yesterday, all these single ones can be squares, but
Okay.
the squares can't be singles.
Okay.
So you went and moved the one over with the secant squared theta and said, hey, that's the same as tan squared. So you replaced this
And then it,
with tan squared. What you could do to make it easier if you wanted to, I'll just do what you said. So you said
cos squared x,
cos squared x.
sine squared x, and then just sine over 1.
Some people might have just changed cotan to being 1 over tan, and then tan squared, and then canceled those off as well. It would be the same thing.
I changed the tan squared x to sine squared x over cos squared x. And then the stuff starts to cancel out.
Okay. Next, what we're going to do is not simplify, we're going to prove.
Are we done this one? No, that we did verify.
We did verifying. We didn't really
We didn't really do proof.
No, we just talked about it. So we're going to do proofs. Now these are the steps that you can use. The catch with proofs is there is no exact way to do any proof.
Oh.
That's why they're kind of like a puzzle. Okay? After you do enough of them, you'll see patterns of stuff that works and makes it easier. Like we're learning now what patterns of this. This is just one side of a proof, right? That's all we were doing. We're technically looking at one side. Now we'll just have two sides. So, and we try and make them match. So proofs. 1. Some things that you can do. You can transform the more complicated side. Of the equation to the simpler side. So always start working on the harder side first. Simpler? Good job.
Sure.
I'm like blanking. Simpler. I want to add an I in there. Okay. And then, so dark. I need a flashlight. 2, substitute 1 or more. Basic trig identities. to simplify expressions just like we did above. What we were doing above was really just working with like one side of a proof. Now we'll just work with two. Sometimes the one side's sine x. You can't do anything to it. You have to really work the whole one side to make it match the other. 3. Factors, or GCF. GCF is often the one that's missed. Like both of them will have a sine x, and you can take a sine x out. And you'll sit there. And often when you're sitting there and you're like, I have no idea what to do, 98% of the time I would say it's a GCF. And I'm not over-exaggerating. It is that much. 4. Multiply expressions. By an expression equal to 1. What does that mean? That means that you can randomly multiply any top by any bottom, the same thing, right? So if when we went to go make common denominators, we multiply the top by sine x and the bottom by sine x, which is just 1. Because you're not changing the expression if you do it to the top and the bottom. So an example could be multiplying by cos x plus 1 over cos x plus 1, which will make sense a little bit. Or we could multiply by sine x over sine x, making common denominators, right? But you're not changing the expression because that is actually just 1. That's why you have to do it to the top and the bottom, because that means you're multiplying by 1, which doesn't change a number or an expression. And then 5, express all trig ratios in sine and cosine. So if you're actually writing out the word sine, you need an E. The only way you know it's actually sine and a trig ratio is because it has an x beside it. If not, it is just the word sin. Okay, in sine or cosine. So I'm going to ask you to prove the following. This is the first one. Cosecant x, secant x, cosecant x over secant x equals cotan x. Now there is a method of which you cannot skip and do differently. So if we do a proof where we want to use the equal sign, we have to have a left side, right side the whole way down. The way to do less work often for both sides is to actually do it this way, where you make a t-table. Okay? So I'll show you. You have to do it exactly this way. You can't like half do stuff. It will not work out well for you. So if you want to do the t-table, which most people pick this option, we ourselves a little table. We go LSRS, or if we want to be super cool, we can go left side, right side. This is the only thing you're allowed to short form. Enjoy it. Take advantage. So on the left side, you rewrite the left side. On the right side, you rewrite the right side. There's no equal sign, okay? So your very first step is to rewrite whatever they gave you. So we're going to go cosecant x over secant x on the left side, and then cotan x on the right. If you use the t-table, you don't have to write left side and right side at the same time every single time. You can work the whole left side, you can work the whole right side. One can be longer, one can be shorter, it doesn't matter. If you don't do the t-table and you go left side equals right side, you have to write a left and a right and an equal sign in between the whole time. And the reason why I switched to this is because people will drop it off halfway. They'll be like sine x, and then they won't write anything, and they'll bring the sine x back, and they're like, well, obviously you can tell it was still there, or they put little dashes or something. It goes badly. So I'm going with this route. So your first step always is to try and simplify what you think is the harder side. So which one do you think is the harder side? The left side? So I don't have to even touch the right side. I could actually never touch the right side and get them to match, and then the left side equals right side, and the right side just sits there. Right? So cosecant x is 1 over sine x. Oh my goodness, it's a fraction. So I'm not going to stack them. I'm going to write it in brackets, so my numerator's in brackets, divided by secant, which is 1 over cos x. Now do I have full fraction and divided by full fraction? Yes, so I'm allowed to flip it. So I take the reciprocal of it, and I get cos x over sine x. Now, I could just go cos x sine x on the right-hand side, left side equals right side. Or I could switch the cos x sine x into cotan on the left and never do anything to the right side. But people will often go left side equals right side, right at this point. They'll go left side equals right side. Well, you are assuming that people know those are the same. That is a problem. You're not allowed to assume. This is what I have to tell you. When you're at the bottom of a proof, I don't know, we'll say a 4-year-old has to be able to look at this and say, oh, the two sides match. Okay? Right now, if a 4-year-old looks here, they go, that doesn't look the same. You understand that? You will rebel against the machine and be like, they're the same. You know that. It's on the formula. Left side equals right side. You will not get the full mark. You won't. I promise you. So you either have to take the right side and write it as cos x over sine x so the 4-year-old agrees, or write this as cotan. I'm going to write it as cotan because the 4-year-old would find that easier. That's just that. I want to be a rebel and never touch the right side. Now would the 4-year-old say they're the same? Yeah, they have no clue what it is, don't even know letters, but they would look and say, hey, they're the same.
Do 4-year-olds not know letters?
Some don't.
When do kids learn?
In kindergarten, some of them only start. And you don't even have to take kindergarten. Did you know that? You don't have to. Mm-mm. Some people come to grade 1 with nothing. Blank slates, really. Not often, but you don't have to take kindergarten. A JK and an SK. Example. Cosecant x tan x. So we're proving all of these because I put the big word prove at the top. Secant x cos x equals secant x if there's no signs yet. So we're going to have left side. I went to go do my old way. That's why that didn't help me. And then right side. And then I have cosecant x tan x. You can't give like a varied version of this. Like you can't start working on it on the first step. Because we are trying to prove this proof, correct? So if you start working on it in the first step, you're not proving that proof. You're proving like the varied version of that proof, which could be totally up to lunch. You could have done something wrong. So if you want to prove a proof, you have to, the first step has to be to rewrite it. Okay? Then we have 1 over sine x over tan x. I mean cos x. I don't know what I was saying. 1 over cos x over 1. The sines cancel, the coses cancel, and I'm left with 1 over cos x, which is secant x. And when I'm done, I have to go left side equals right side. If you forget ls equals rs, you will lose marks. No. So for this one, you're going to have to go LSRS sine x over 1 minus cos squared x, and then cosecant x. So you get sine x, quiet please, over sine squared x is cosecant x. Oh, I'm so used to doing proofs the other way that I write left time. It's at half time. I squared cancels this one out, so I'm left with the 1 on the top. And then I can go from here to cosecant. See that? Yeah.
Is it fine if you just put it into like sine x over 1 divided by a bracket sine squared x over 1 and then like flip and multiply? Okay, I can just show 4 steps.
Sine x over 1.
Like, you know how sometimes we write out the like full penetrated ratios?
Oh, you wrote it as a fraction of flipped. Yep, totally fine. Gotcha. Okay, Trying this one out. Cotan A equals cos cubed A over sine A minus sine cubed A.
You're done.
No, thank you. I don't deal with numbers like three.
GCF, people. GCF.
Three is a fake number.
It's not. You literally just rewrite the word once, and that's less than even substituting. GCF out of sign. So I have to go LSRS, and I have to rewrite it. You will have to stop yourself from trying to do work before rewrite it. You have to rewrite it. Okay. When you're stuck, 98% of the time I've told you it's GCF, I'm not joking. That's true. You can take a sine A out of the bottom of here. So we get cos cubed A over sine A. And when you take a sine A out of sine A, what are you left with?
1 minus sine squared.
1 minus sine squared A, which is what?
Cos squared A.
Cos squared A. And then we're done. We're not, but we were close. So we get sine A, and then times cos squared A. And then these can cancel. Because is there plus signs anywhere in here or minus signs anymore? No. So then I can actually cancel these off. 2 for 1. Or 2 for 2 out of here, and I'll be left with 1. So I'm left with cos A over sine A, which is cotan A. Left side equals right side. It's the same thing. Okay. Left side, right side, tan A, sine A, minus sine cubed A, over cos cubed A. You guys are going to try that one on your own. Okay. You should be able to. It's a replica of this one. Just numerator, denominator mix. Okay. I want you to try this one. We're paying attention. We're going to work together on this one. Sine X, cos X. And I would start this one because this one's the one that most people get stuck on. It's not as obvious. As long as you remember one thing, it's really easy. 1 plus cos X equals 1 minus cos X tan X. Mm-hmm.
If you use equal signs, then you just rewrite it and use.
Well, you should always rewrite it. You shouldn't try and work your work out of the question. Yeah. Like this would actually be a typed part, correct? So you would rewrite it because, yeah. Right now it's in your own handwriting because you're writing it, but on a test it would be typed, and you don't ever want to work off the typed part. Yeah. Okay, so the only thing I can see here that I could do is maybe the tan X. So people will always try that first. So they're going to go 1 minus cos X divided by sine X over cos X. Oh, I have a fraction, so I'm going to write it sideways. I'm going to put it in brackets, and then I'm going to sit there and stare at it for a little while and say, okay, well, they're full fractions, so I can flip them, right? So I get 1 minus cos X over 1 times cos X over sine X. What I have to send home to you here is if you have a 1 plus cos X or a 1 minus cos X, never distribute the stuff with it. So like, don't distribute this cos in, or you're just going to have GCF it back out, right? So if you have a 1 minus cos, if it's a squared, you'll switch it. But if it's a single, you're not going to distribute it. So I'm going to get 1 minus cos X over 1 minus cos X times cos X over sine X. Then I go, oh crap, I'm out of ideas. But what you do is you look and you see what is there that's the same. So currently, do I have anything that's matching? Well, I have a cos X on the top, and then nothing. Okay? When you're stuck with a 1 plus cos X or a 1 minus cos X or a 1 plus sine X or a 1 minus sine X, or a 1 plus tan squared, or a 1 minus tan squared. Look at these. You go to the Pythagorean theorem identity. The reason why is this. I'm going to let this one sit for a second. Nah, I'm going to work with it. Okay, I'm going to let it sit. I'm going to work with this one. So I'm going to I'm never going to do this to both sides. That's going to be counterproductive. I'm going to either multiply this right side by 1 plus cos x over 1 plus cos x, or I'm going to multiply this left side by 1 minus cos x over 1 minus cos x. Just the opposite. Because then you're going to get a difference of squares, which is 1 minus cos squared x. So try this one and see how you do. Don't put this in here. Go like this, 1 minus cos squared x, and see if it helps you. Because your middle terms are going to cancel. And we'll go through the rest of it on Monday.